This is the blender in its entirety. As you can see here, this is the bowl, which has a lid, as well as a cap to that lid. And inside there's the blade assembly, which we will talk about later. This is the casing, which pulls apart from a plastic bottom that houses the motor and the circuit board. This is the motor. And this here is the circuit board, which carries the resistors and connects, uses the buttons to connect those resistors, which we will explain later. The bowl with the blade assembly inside, the motor, the circuit board, and the casing, top and bottom, all make up the overall assembly of this product. This here is the circuit board assembly. It's currently split up into two parts, one side with the circuit board and this side, which has the buttons connected to it. There are 8 in total. Each button, when pressed, they will connect. As you can see, it'll protrude through on the other side, and that will in turn connect on the other side one of the resistors that you can see here. There are 5 of a certain type, and then 2 more, and then there are also 3 capacitors. What happens with the capacitors is as they get charged up, once they are fully charged, they will create a short in a loop of the circuit, which that will cause the current to have to flow through other loops. These are the 2 blue resistors, which those are for the high and low feature. They have a certain resistance, and those, what happens is they become connected after the high or low button is pressed down, and you can either hit the smoothie button or one of the others, and it will connect one of these other 5 resistors, which has, each of them have different resistances, and those resistances will create an equivalent resistance, which in turn will limit the amount of current that flows through the circuit. Here we have the motor assembly, which has these 2 wires, one in and one out, that will connect to the circuit board. What these will enable the motor to do is it will transmit the current from this circuit board that we explained earlier down into these current coils. Now these current coils are made of copper, which is a pretty conductive substance, and it will flow through, and either through AC it will oscillate through those, or DC it'll just run through in one direction, and those take the current up through those, which is brushes, and they, for DC, it puts them onto this center copper part, which conducts the current from that down into the copper down below, which then carries a current and induces in a magnetic field, which creates torque spinning the shaft at the center, which is connected to this fan. And there is one large fan and a smaller one, as you can see down there, and those are connected to the shaft, which work to keep everything cool in the engine and prevents overheating. There is a bracket here, a top one and a bottom one. What those do is those help house the motor to this center casing, keeping everything contained as it is running. Because when things are moving, it has an angular a moment around the center axis, and if that was to turn, it would create a lot of vibrations, which would be bad. And this is the center shaft, and this spins as the center does. And what happens is that will then connect to the blade assembly, which we'll talk about next. Here we have the motor assembly that we explained earlier connected with the blade assembly, and that gear wheel that we talked about earlier at the end. As you can see, it spins, and that will connect here with another wheel gear that meshes with it, which takes the power from the motor. As you can see, they connect, and it takes that power and it turns the blades up top. Now this is a convenient way of transmitting the power because you don't have to work with a differential or anything like that. And see these two blades, there's one on top and one on bottom, and it's the same blade, just they're flip-flopped, and they're placed on top of this bearing here in the center. And what that does is it spaces it from the bottom so that food isn't caught, and it also helps the blades rotate. And they're held together by this rivet type screw, which as you can see comes through and is connected to the bottom, and that runs to the center. This is the outer casing for the blade assembly, and what this does is it's a really smooth surface, and it helps prevent the food from getting caught and everything. This here is the bowl subassembly. We have the blade subassembly that we just got done talking about, and that fits in at the bottom here, and it's got a nice little groove for it to drop into, and there's a rubber washer ring, which as you can see there, it has a couple grooves which helps seal it down to the bottom of that blade assembly, as well as to the base of this bowl that will screw in. And as you can see, there's threads there that will correspond with the threads inside there. And as you tighten this down, that rubber washer ring that we showed you earlier will seal off, not allowing anything to, like any liquids to seep out from down below. And this here is the lid. It's just a plastic lid, and that will fit in on top, keeping anything from getting out the top. But as you can see, that there's a hole in the center of it. That is going to be a something that we'll look at later when we're talking about things to make it better. And this is a nice little cap that will plug up that hole, and as you can see, it just locks into place, creating a nice sealed container that won't let any liquids out. So here are all of the parts that we got done talking about. We have the aluminum casing, which has that faceplate, which as you can see has the different speeds that you can run it at. We have the plastic bottom, which will help house the motor as we put this back together. And that has the 120 volt cord that just plugs into the wall connected to it as well. So this is the motor. The shaft will fit up through that, and it'll lock into a little groove up there. And next we will take the buttons, and they fit through a hole there, and the circuit board will rest nicely. And as you can see, the hole is roughly the same size as the motor, and that will fit right over the top, letting everything seal up, and that sits down. And normally we would fasten the screws onto this, but for time's sake we're not going to. And that spinner wheel, or the gear wheel that we talked about earlier, has a little groove on the bottom that's the size of that shaft, and it fits into place. We take the bowl as well as the blade assembly, and it drops right in, and we have the blender put back together.